Alright, so today we're going to continue our discussion into velocity. And instead of talking about an average velocity, we want to talk about the velocity right now. We want to talk about instantaneous velocity. And again, velocity is a vector, so it's magnitude and direction, and it's what's happening right now. So I got Buzzy the bee here, flying from his flower up and around. You can see his displacement as s. Well, his velocity now is going to be pointed this way off the vector. And as we shrink this, though, we actually know he's headed this way, and that'll give us the instantaneous velocity. What I show right here is the average velocity. And we do that by shrinking the displacement. Just like on instantaneous speed, where we change the distance to be very small, we take the limit as delta t goes to 0 of the change in displacement. So going back to the previous slide, instead of looking at the average from here to here, we'll actually start looking at displacement from here to here, which will put the instantaneous velocity off in that direction. Again, a much more representative situation of Buzzy the bee here. So again, if we take a look at Buzzy the bumblebee, you can see I've written out his S initial and S final, and instead of going from here to here as a long final, I'm doing a delta S here, which will put my instantaneous velocity off in this direction, whereas the average would actually be out this way. And again, it tells us the speed he's going now. It's very hard to do. We have to decrease the displacement and look at very small intervals. And again, just like I was showing on the last slide, while the black vector here will be the average velocity, or the red one will be the average velocity, I'm sorry, the black one is the instantaneous, because again, it depends on where we're looking. So it's a little bit different. But again, what's more of an accurate number for Buzzy the bumblebee? Well, while the average is nice, I want to know where the bee is going. So the instantaneous velocity is actually a little better. It's easy to think about instantaneous velocity and hard to quantify. So a lot of times we have to do the best we can with inaccurate information. So as we look at these situations, we have to do the best we can to figure out a change in displacement. And that means sometimes answers with your neighbor won't be quite the same. But again, we know which way Buzzy is going.